Alright, welcome to this video on creating a hex nut to fit onto this hex bolt. This is a continuation of the prior video showing how to create a nut and bolt assembly based on a tutorial that TooTallToby did using Onshape. Now, the workflow for this nut creation is going to be slightly different than what Toby used on his video because Alibre does not allow or does not have the ability to do multi-part modeling or multi-body modeling. So I cannot create my hex nut with or alongside or in the same workspace as my hex nut. I can, however, do that in an assembly workspace. So what I'm going to do is I'm going to go to my home window, and I'll open up an assembly, grab my hex bolt, open that, and place it, and then let me resize my window here. Okay, and now I've got my bolt assembly. Let me show my reference geometry and constrain that to the origin. And I'll grab my y-axis and my x-axis and apply that. So now this is locked at the origin. And now I go back to the hex bolt that I had open previous, and I'm going to close this window. The reason I did that is because I only want one instance of my bolt open at a time. If I'm going to do any editing on a part and you have it in an assembly, you need to edit it. You need to right click on that part and edit in a separate window. And then when you're done, close that window to return to your assembly. The reason for that is that if you open a part, if I open up this hex bolt outside of my assembly and modify it, and then save it and close it, those changes are not going to reflect in my currently open assembly. So let me turn off reference geometry here. And now in this assembly workspace, I can insert a new part. So I go to Insert menu and select New Part. What happens is my ribbon on top changes to a part modeling ribbon. I have a new part in my Design Explorer, and I am launched into that new part assembly workspace or new part design workspace. So the first thing I want to do is create an offset plane or plane offset from this face of the hex bolt. So I'll insert a plane and I'll offset that 25 and apply, and then close that. And now I can create a sketch on this plane. So we'll activate a 2D sketch. And in this case, we're going to project, same as what Toby did, we're going to select this face and project that face of the hex head into my sketch. I'm going to maintain association to the source and click OK. So now right away we've got the profile or the outline of the hex, but we also have this inner circle. So if we right click on one of these arcs and select chain, and then we hit delete to get rid of that. Bring up our sketching in place menu and hit circle, and we want to put in an 18mm circle in the center. And one more circle we need, and that's going to be a reference circle. Because we only selected the face, we cannot select the sketch that would have brought up our reference circle in here. So we grab our center point, drag out, and as soon as we manipulate your mouse so that you get a tangent symbols on all of your arcs or on the lines, and then click to place it, and now we're complete. And then middle mouse button to bring up our part editing menu, go to extrude, change this to a mid plane, and that's going to be 20, hit enter and OK. So now we have our hex bolt or hex nut with the hole in the center. We can come up here to our hex bolt and hide that. So the only thing we're dealing with is our hex nut. So now on the XY plane, we're going to again activate a 2D sketch, and same as we did with our hex bolt, we're going to sketch some figures up here so that we can trim off the corners of the hex nut. And here we need our tangent arc. Select the right end of the line, and then drag down to the point on the vertical line. And then to constrain this, we're going to go to constraint or project to sketch, and we're going to grab our sketch from the hex and make that reference figures, and OK that. And then we'll finally come in here, we'll do a vertical constraint between the end of this line and this node from the arc. We'll do some more constraints, do a collinear from this line to an edge, and we could do a line for collinear also from this line to this edge, and then resize that a little bit. We'll get a dimension on this line at 2.5, and then again we'll go up, select our revolve cut, select the y-axis as our axis, and we get a preview. All of our corners are trimmed, and while that revolve is still active or selected, hit our mirror tool, select our mirror plane as our sketch plane, and our trim is mirrored to the bottom of the hex bolt. One more thing to do is do a chamfer on the hole in here, so we're going to do a 5mm chamfer. And for this, you can either select each edge individually, or in this case, just select the face of the hole, and both ends are chamfered in one selection. Okay, so now we have our hex nut pretty much defined except for the thread, so we can back up and right click on the bolt in the Design Explorer and reselect hide so that's shown. And we're still in the part workspace, so right click on new part and select edit root assembly. So now we're back in our assembly workspace. And while we're here, let's go ahead and click on the save icon, and we'll save this as our bolt nut assembly. And a new part is going to be the hex nut. So enter that tab and then hit OK, and our bolt nut assembly is saved and our nut is named in the Design Explorer. Okay, now the next step is to do a Boolean subtract to subtract the threads of our bolt from our hex nut. And in order to do that, we're going to right click on our hex nut and edit this in a separate window. Let me resize. Okay. Now in here we're going to go to Boolean subtract, grab our hex bolt, bring that in, click once to place one instance, right click on this, show reference geometry, and then constrain this similar to our assembly with our y-axis and the x-axis. And then we can right click on that and deselect show reference geometry and commit the Boolean, and there's our thread transferred or cut away from our hex nut in its normal orientation, normal position. Now notice in our bolt or hex nut here, we do not have a save icon available. Even under File, we don't have save or save active because we open our part in our assembly or from the assembly. We have to go back to our assembly in order to save this. So now we can save. We're going to bolt, our nut is modified, our assembly is modified, so click on save and the parts are saved. go to our Inspect tab, activate the XY plane, and turn off toggle plane so we don't accidentally move one of the planes. And we can see that our threads are cut into the hex nut, but there's no clearance. So let's go back to our assembly. So now we're going to resize the threads in our Boolean, or in our hex nut, so that when we do the Boolean, we get clearance in our hex nut. Now, just to be clear, let me open up the hex nut in a separate window. If you notice, I've got to edit the Boolean. There is no option in the Boolean to offset the planes or offset faces. So I can't do like what Toby did and offset faces in the Boolean feature. So what I'm going to do is create some offset threads on the hex bolt. So when they are offset in the bolt, we're able to select them in the Boolean to get our clearance from the hex nut. So we'll open up our hex bolt in a separate window. And now remember, when we created our hex bolt, we created this with our normal thread. So the threads was turned so that helix was normal to the path of the helix in our advanced tab. So we have our thread profile as normal. So what we're going to do is use that name normal. In a sense, we're going to create a configuration in here. Go to configs. Let's rename our config 1 here to design size. And now we're going to resize our threads. So we'll create in a new config. We'll change this and we'll name this one scale normal thread, and then we'll make it active and hit OK. Now, just to illustrate what I'm doing here, I named it normal because our thread helix is set to normal. And if we want to move our faces, if we come in here and say offset face and select the faces that we want to offset, so we select all of these faces for the thread and key in a value of 0.4, we get the cherry colored apply button, but it errors out because in the status there's no solution for an edge. So Alibre won't let you do an offset face there. So let's delete this. So what I'm going to do here is I'm going to go to scale mirror part. And under the scale type, I'm going to select non-uniform. And I'm only going to scale this in the X and the Z directions. I don't want to scale it Y, which is vertically. I want to scale it in X and Z, which in effect is changing the diameter. So I'll key in a 1.04 in the X tab and 1.04 in the Z, and apply that. And now if we toggle between the two configurations, design size and normal, scale thread normal, you can see that it grew in the diameter of our part. Okay, so put that back into design size, and I'm going to close this window. Now on my hex nut, I'm going to edit this in a separate window. And I'm going to go and edit my Boolean. And now this time under the hex bolt, I'm going to go to configurations. And now, because I only edited this hex bolt, in the context of my assembly, this configuration is now available for me here in my Boolean. So if I double click to activate that Boolean and then commit the Boolean, now we close the window, back in our assembly, come up here to our inspection tab and activate XY. And there you have your threads oversized by changing the scale of your part in XY, and you have your clearance cut into your threads on the hex nut. So now that's one option. If I go back into let me go ahead and save this assembly, because we have our modified bolt and nut assembly. We'll save that. Let's go back into our hex bolt. We'll edit this in a separate window. Now if we go into our configurations and we'll change another, or add another configuration here. And this one I'm going to call offset parallel thread, and activate that. So it's going to be our current configuration. I'm going to go into my helix. We'll edit the helix, go to the advanced tab, and we'll change this back to parallel. And what that did is it got rid of that extra surface on the outer face of the threads. We'll OK that. And now if we go back and we look at design size and offset parallel, notice that the change in the outer face or surface of the thread is now a single surface. And the other thing we want to do is come up in here, and we're going to do a offset face. And now we're going to select these same faces of the threads, and we're going to do an offset of 0.4. And now we could do an apply on there, and now the offset face is applied, and toggle between normal and offset parallel. You can see the size change in our threads. So let's do one more. Go back to design size, and I'm going to add one more configuration, and this will just be parallel thread, and make this active. And then this helix, edit this, and I'm going to change this back to normal. Oop, I should have renamed my let me edit this. And parallel. There. All right, now. So we have parallel thread, design size. The only change here between design size and parallel thread is the helix direction, either parallel or normal. And then we have an offset parallel to go inside with parallel thread at design size. So now we can close this, and we're back in our assembly. We'll right click and edit the nut in a separate window. And now in our Boolean, we'll edit this, our hex bolt configurations, and we want to do offset parallel, and then OK that, or commit that Boolean. We'll close the hex nut, And then on our assembly, we'll change this to parallel thread so that it matches the offset parallel thread in the hex nut Boolean. And we'll look at our threads, and there we have our offset, our clearance designed into our threads again. So there's a couple of ways for creating the hex nut with clearance, and so I guess it's a matter of whatever suits your fancy, whatever you feel comfortable doing. You've got a couple of methods of creating the offset thread for your Boolean to create clearance, and those adjustments can be made depending on what you need for your respective 3D printers. So anyway, hope that you find these tips helpful. Talk to you later.